Tonight we're going to talk about another method to solve linear systems of equations, and it's called the elimination method. And where the name comes from is we're going to work with both equations at the same time with our end goal of trying to eliminate one of the variables completely and end up with one equation with one variable that we can solve and find that variable, and then we'll have to calculate the other variable, and we'll see the process here. These are the steps. I'm not going to talk through all of these. I would recommend pausing your video here and writing these down. These are the steps we're going to follow on the next 2 to 3 examples we'll do today. So a couple of things you'll hear me talk about is to make sure the variables of the two equations line up. That means the x's are on top of each other, the y's are on top of each other, and the constants are on top of each other. Our ultimate goal comes down to this right here of making the coefficients opposites for one of the variables. So they're the same number but with different signs. That's very important. That's the key to this whole process. What we'll do is we'll then combine those two equations, which will eliminate one of the variables, and then we'll have to solve for that remaining variable. Once we have that number, as we're down here, we'll substitute that value back into one of the original equations to get the second variable, and that will be our process. Again, that's very vague. I understand that, but keep these notes in front of you here as we go through the next couple of examples, because these are the steps that we will be following. So if we look at this first example, we started basic and are working our way up. What's nice about this one is if we take a look at the y values right here, we have -3 and +3. Okay, -3 and 3 are opposites. Okay, and they're with the same variable. The x's line up, the y's line up, and the constants line up. Sometimes we'll get a problem like this where it's already in the form that we need. Okay, these -3 and the 3 they're opposites. That's what we need, because now when we combine, we're essentially adding 2x and 4x will get us 6x. -3y and +3y will be plus 0y is equal to 8 plus 16 is 24. Now what this does, and I'm actually going to erase it, but this 0y comes from these two being opposites, and that's where we're going to eliminate the y variable. So here we go. I'm going to have to erase those real quick right here. So now this is 6x equals 24, and we can solve that. I know we can. Divide both sides by 6. I get x is equal to 4. All right, now you might be saying, well, what about y? How are we going to find out what that is? And what we'll do is we'll take this x equals 4, and we'll substitute it back into one of the equations. I'm going to go ahead and use the first one because those numbers seem to be a little bit smaller. So I'll have 2 times 4, because that's where that came from right there, minus 3y is equal to 8. And we have to solve this. So I get 8 minus 3y equals 8. From here, we have to subtract 8 from both sides. We get -3y equals 0. Okay, so -3y equals 0. Divide both sides by -3. We get y is equal to 0. What that does is it gives us our final answer of 4, 0. That's our final answer. That's the basic. Now, every question we do, every system that we can do by elimination, will eventually get to this point. The other problems that we're about to see, we'll just have to do a few things before these problems look like this. So what I mean by that is we won't always have the opposites given to us. we'll have to create the opposites, and then the process is the same as this. So we'll take a look at a couple of those examples here. If we take a look here at these, none of these are opposites right from the get-go. I have 3 and -4, 5 and 2. But what I am looking at here is I'm looking at the fact that these, first, the x's have opposite signs already. I have a positive 3x and I have a negative 4x. So I'm going to go ahead and work with these ones. And now what we have to look for is the least common multiple of 3 and 4. And what that is it becomes 12. It's 12. So what we have to think of is, what do I have to multiply 3 by to get 12? And what do I have to multiply 4 by to get 12? So as we go through this, I'm going to take my top equation and actually multiply every single term by 4, because 4 times 3 will give me 12. So what that does is I get 12x plus 20y equals 24. That 4 gets distributed to all 3 terms in that problem, in that equation. The second equation here, I'm going to multiply everything by 3, because 3 times 4 would give me 12. So 3 times -4, though, will actually be -12x. 3 times 2y will give me plus 6y. And then 3 times 5 will give me 15. So what we've done here is we've created the opposites with the 12 and the -12x. So what we can do now is we can combine these. 12 and -12, those are going to cancel. I'm not even going to write it there. 20y and 6y is 26y. 24 and 15 is 39. So we get 26y equals 39. If we were to divide both sides by 26, both terms are divisible by 13, so it does simplify. It'll end up being 3 over 2. So our y value is 3/2. Our next step, we've solved for one of the variables, and now we have to go back and solve for the x variable. So what we will do is we'll substitute, and I'm actually going to use this original second equation. And the reason I'm doing that is I'm seeing 3/2 with the y, and that's going to be the easiest one to work with. -4x plus 2 times 3/2 equals 5. Now what I will suggest is to always use one of the original equations, because they typically have smaller numbers. Because as you saw here, we had to multiply, create bigger numbers. The smaller ones are typically nicer to work with. We got -4x plus 3, those 2's cancel, is equal to 5. Two-step equation we've been solving all year. Subtract 3 from both sides. We get -4x is equal to 2. Divide both sides by -4. We get x is equal to -1/2. So that would give us our final answer of -1/2, 3/2. Final answer right there. And you saw we had to multiply both equations there, both of them. So that's another example. What this problem is, and I'm only going to do part of it because we're getting kind of long with this video, is this is one where everything doesn't line up at the beginning. Okay, so what we'd have to do is get this so that all of our x's and all of our y's line up. If I'm looking at this problem, I am going to add 5x to both sides of my second equation. That gives me 5x plus 2y equals 12. And I could actually bring down this next part, 3x plus 2y equals 8. And this would be the system that we would solve. Now what I'm going to ask is you to try to solve this part on your own. You actually, I'll give you a hint, you can get away with only multiplying one of the equations. Because remember, we need opposites. We have the same coefficient somewhere, but we don't have opposites. We'll start tomorrow's class. We'll include this as part of the ones we check with our warm-up, and I'll see you in the morning.